In a small saucepan, combine all ingredients. The sauce mixture is homogeneous. Bringing it to a boil is endothermic because the sauce takes in the heat from the pan. Mix well and stir constantly until bubbly. When the sauce starts to bubble, put water in the sauce, which reaches its boiling point. We keep boiling for another 3 minutes. The water passes the boiling point and starts to evaporate. This is a physical change since the water has changed from liquid to gas. It then creates a thicker sauce. When adding baking soda, it acts as an anti-acid, which will neutralize the acidity in the tomato sauce. Remove from heat, set aside, let cool down. Before using, letting the sauce cool down is an exothermic reaction since the sauce releases the heat to its surrounding.
When you add the yeast, the sugar, and warm water, it is a homogeneous mixture because the yeast and sugar will dissolve in water. And stirring the mixture and using warm water help the yeast and sugar dissolve faster. The yeast feeds on sugar and converts into glucose. The glucose is then broken down by an enzyme in the yeast to produce ethanol and carbon dioxide. This process is known as fermentation, which converts sugars to acids, gases, or ethanol.
Let the mixture rest in 10 minutes in a warm place. This is a mixture after 10 minutes. The foam is the evidence of the CO2 producing. Mixing together the crust ingredients creates a homogeneous mixture. When flour is mixed with water, it turns into dough. It also produces gluten, a strong, sticky, stretchy protein. The yeast goes on to break down complex sugars in flour and produces carbon dioxide, which makes the dough rise. Pour olive oil, since it will not mix into the water. When we use oil in the dough, it helps to keep moisture from the sauce and toppings away from the dough during and after baking, resulting in a potential crispier crust. When ready, you dump the whole thing on a floured surface. When you knead the dough, it is a physical change because you are constantly changing the shape of the dough. Kneading helps smooth out all the clumps and chunks in the dough. It organizes gluten proteins into networks to increase elasticity, which makes the dough even stretchier. Kneading also helps to distribute carbon dioxide evenly during fermentation. Now we are coating the dough in olive oil so it doesn't dry out when it rises. Now we will be covering it and leave the dough in a warm place, which is also known as proofing. After proofing, the dough doubles in size, which is a physical change. This is the dough after 1 hour. We drizzle a little of olive oil onto the baking tray to reduce the surface tension. By doing this, the dough won't stick to the tray while baking. Take the dough into a round shape onto your baking tray. Break the dough to release any steam while cooking. Now we are going to put the sauce on the dough and spread it out. We chose mozzarella cheese because in mozzarella cheese, proteins are loosely packed with lots of water interspersed between them. In other words, it is high in moisture. The water acts to loosen the protein network in cheese, allowing more flow as the temperature is increased. That is why when it reaches its melting point, which is 140 degrees Fahrenheit, it liquefies. Now we are adding the pepperoni. When you add all these toppings, it is a heterogeneous mixture because you can take out the pepperoni and cheese from the dough. We are also going to be adding some cheese on top of the pepperoni. When it's done, it is time to bake the pizza. This is an endothermic reaction since the dough takes in heat from the oven, and so do the cheese and toppings. As the temperature rises, the yeast activity does as well, and when the temperature reaches 50 Celsius degrees, the yeast dies and fermentation stops. This means that when you first place the dough in the oven, you will see it rise, and then at one point it will stop rising. There is a Maillard or Browning reaction going on during baking. When heat is applied, amino acids and sugar in the dough, cheese and pepperoni break down to combine and form aromatic compounds, which are responsible for the smell and flavor. The Browning reaction happens on the crust, toppings, and cheese. When the cheese meets heat, it changes from solid to liquid, which is a physical change. The bonds holding together casein proteins break, and cheese collapses into a thick liquid. After it's done, you take it out and let it cool down. This is an exothermic reaction. The pizza made a physical change because it changed the shape of the pizza. When the pizza was baking, gluten in the protein denatures and hardens. This is why the crust is firm and doesn't feel gooey. Water inside becomes vapor, expanding the dough. Some ingredients in the dough release carbon dioxide. We can see the evidence of carbon dioxide when we cut the finished product. All the tiny holes in the crust are caused by this gas. Now that is the end of our video.